we're going to go ahead and take a look at a problem solving an equation that contains a radical expression within it. So the problem that we're going to go ahead and take a look at is going to be the square root of 2y plus 1 is equal to 1 minus 2 times the square root of y. So the main idea behind this problem, or the main goal, is that you do still want to solve for the variable. The challenge lies in the fact that you have multiple y's in the problem and both are underneath separate square roots. So to begin, I would say you would want to tackle the square root with a larger expression underneath it. So in order to break that expression out, we are going to have to square it in order to get rid of the square root, because a square, meaning the exponent of 2, is an inverse of the square root. So now we're left with 2y plus 1 is equal to 1 minus 2 root y, and that entire difference squared. So we're going to have to do a little bit of work with what I have boxed here in red. And to deal with that, we're going to go ahead and create an aside. So we're going to have 1 minus 2 root y times 1 minus 2 root y. And really what I did was I took the expression that I had boxed and I expanded it out. So now what we will do, if you guys are taking a look at this, your instinct is probably telling you to FOIL. So if we FOIL, 1 times 1 is 1. 1 times negative 2 root y is going to give you negative 2 root y. Negative 2 root y times 1 is going to give you negative 2 root y. And then finally, we'll do negative 2 root y times negative 2 root y. And what that will become is negative 2 times negative 2 will give you a positive 4. So I'm multiplying my outside numbers with my outside numbers. And then I will also multiply my two radicands together. So the square root of y times the square root of y will equal the square root of y squared, and then it takes us back to that same idea of the square root of y squared just becomes y. So we'll go ahead and we'll write this in. So 2y plus 1 is equal to 1 minus 4 root y. So I went ahead and I combined my like terms plus 4y. So from here we should be trying to continue to clean this up and consolidate this down. So, for example, I might want to combine like terms by subtracting 1 from both sides, and lucky me, they just so happen to cancel each other out. Next, what I would like to do is maybe subtract 4y from both sides. And this is going to give me negative 2y is equal to negative 4 root y. Now, I specifically wanted to get the y on one side and the square root of y on the other, because I'm able to efficiently now get rid of that square root. So what I'm going to do is, again, in order to get rid of a square root, I'm going to square both sides. And again, I do that because I need to maintain balance between the equation. What I do to one side, I must do to the other. So negative 2y squared will give us a positive 4y squared, because negative 2y times negative 2y will give us 4y squared. And negative 4 root y squared will give us positive 16y. Okay, so from here, if I subtract 16y from both sides, I have 4y squared minus 16y is equal to 0. Now I kind of have a simple equation where all I really have to do is do some factoring. So if I do some factoring here, I note that I can pull a common factor of 4 and y out, which would leave me y minus 4 is equal to 0. So now I have my zero product property here. So I can say, well, if 4y times y minus 0 equals 0, then I can guess that either 4y is equal to 0 or y minus 4 is equal to 0. If we solve for these guys, then we see that y is equal to 0, or y is equal to positive 4. So these are my answers up until this point, but what I really should be doing is I should do a check to make sure that I didn't create any sort of extraneous solutions. Because as we were squaring everything, we kind of messed with the signs of the square root of the equation. So sometimes what we end up doing is getting these extraneous solutions or false positives. So if we were to go ahead and check these, we would use the original problem. So we would use the square root of 2 times 0 plus 1. So I plugged 0 in for my y, and then 1 minus 2 times the square root of 0. If we clean this up, then we get 0 plus 1 is equal to 1 minus 2 times 0. Clean this up further, square root of 1 is equal to 1 minus 0, or 1 is equal to 1. So that checks out. Let's try it with the other solution that we came up with. So we would have the square root of 2 times 4 this time plus 1 is equal to 1 minus 2 times the root of 4. And as we clean this up, we get 8 plus 1 is equal to 1 minus 2 times 2. And then this becomes the square root of 9 is equal to 1 minus 4. And this is 3 is equal to negative 3. This is an error. 3 is not equal to negative 3. They're actually opposites of one another. So this solution that we have here is extraneous. And there you have it. There are your final solutions.